Hello, my name is Emma Underwood and I'm a researcher at the University of California, Davis. The title of my talk is Estimating the Impacts of Wildfire on Ecosystem Services in Southern California. So this project was taken out in conjunction with the US Forest Service, and our aim was to really increase our understanding of ecosystem services associated with shrubland-dominated ecosystems, and also to understand the impact that wildfire has on these services. So our study area is shown in the map on the right, outlined in black, and in colour you can see the 4 southern national forests. And as you can see in the map on the left, the purple colours indicate shrubland vegetation, and we can see that this ranges from 56% in the San Bernardino National Forest to 82% in the Cleveland National Forest. So really, the study was trying to really increase our understanding of the chaparral shrublands. So just to summarise the project, we identified priority ecosystem services based on meetings with resource staff and ecologists in Southern California. We ran models and compiled data, and this included the integration of fire conditions. We also determined economic values and costs. And the overall objectives of this work were to be able to quantify services in pre- and post-fire condition, to estimate the associated change in economic values associated with this change, and also to develop a web mapping tool for resource managers. So the ecosystem services that we assessed included water runoff, groundwater recharge, sediment retention or erosion avoidance, carbon storage, biodiversity, and so what I'll do first is show you some of the data layers that we have compiled on each of the ecosystem services, and then show you some screenshots of the web mapping tool that we've developed. So first of all, in terms of water runoff and groundwater recharge, we're using the basin characterization model, which is a hydrological model for the state of California, and its cell size is 270 meters. So what we can see in these maps here is that the higher values of runoff and recharge are shown in the bluer colors, and then lower values as you move more towards the yellow. The national forest boundaries are shown in the red lines. Now, to integrate the effects of fire into these data sets of runoff and recharge, we used burn severity data, and these were derived from the rapid assessment of vegetation condition of the wildfire. And this is an assessment that's done by the Forest Service on any fires over 1,000 acres on federal lands. What's done is the normalised burn ratio is determined on Landsat imagery, both pre-fire and post-fire, and a couple of the outputs that are given include the percent basal area lost and also the percent change in canopy cover. And we focused on the percent change in canopy cover and integrating that into our hydrological model. So for this example, we can see the ravage data for the copper fire. And you can see those pixels in red have between 75 to 100% canopy cover loss. So what we did then was to rerun the basin characterization model using a decrease in the amount of vegetation. And so we captured the post-fire change in vegetation canopy cover by rerunning the model at the percentages shown on the right-hand column. So pre-fire, we would use runoff data from the year before the fire, and for post-fire, then we would integrate the burn severity data and rerun that hydrological model to give us our post-fire estimate. For sediment erosion, we modelled this using the INVEST software for the Natural Capital project. This is at 30-metre resolution, and we tailored this to Southern California by developing an erosivity index for Southern California based on the precipitation patterns there, and also using relevant Landsat data, land cover. And again, the INVEST model was rerun with different percent canopy cover loss classes to integrate the impacts of fire. We also looked at above ground live biomass and the associated carbon storage with this. And for this, we estimated it using a random forest model. This included dynamic predictors such as NDVI derived from Landsat and precipitation, and also some static predictors such as slope and elevation. And this was generated at 30-meter resolution. There's a talk by Charlie Schrader-Patton that describes this in more detail. Here's an example of the those biomass outputs for the Thomas fire in 2017. We can see on the left the pre-fire estimate. So blue colours indicate higher above ground live biomass. And then yellow and red colours are lower levels of biomass. And we can see the difference between the pre-fire image and then the post-fire image, which is dominated by more yellows and cool, hotter colours, indicating less biomass. We also looked at recreation, and for this we worked with partners at Michigan State University, and they used the US Forest Service National Visitor Use Monitoring Survey data to create a recreation demand model. So this National Visitor Use Monitoring Survey data is collected every 5 years on each forest. And based on this, they related travel costs to get to and from a site to the characteristics of that site. And so by doing that, they were able to calculate the value of different recreation sites on the national forests. And then the assumption then is that when there is a fire, that these recreation sites will close, and that leads to the calculation of the economic value associated with that closure. For biodiversity, we compiled a number of different input data layers. As you can see here in the upper left, we've got the California Natural Diversity Database. We've also got linkage corridors for key species that have been developed by a couple of different assessments. We also included native species richness and also native species rarity. And also we included data from the watershed condition class assessment by the US Forest Service, and we've included any watersheds which were indicated as having good aquatic biota. So for each of these data layers, we identified a conservation target, and then we put these data layers into Marksan conservation planning software, and came up with an output which indicates the irreplaceability of these different areas of the landscape. So areas in blue have a greater importance for meeting the goals for each conservation target that we set. Just to show you how we can use this data, for example, on the Sand Fire on the Angeles National Forest, this is about 51,000 acres, and about 80% of this was chaparral. And so here we have a number of different ecosystem services here: recharge, biodiversity, carbon storage and sediment retention. Just as an example, the blue colours are higher values. And then we scaled these, and then we overlaid them to identify hotspots of services, which we can see in redder colours in the map on the right. And this map of the ecosystem services hotspots can be combined with areas of restoration need that have been identified by resource staff on the ground. And by overlaying those two, we can identify potential areas for restoration. So this is one example of how the data we've been compiling on ecosystem services can be used. What I'd like to do now, though, is to show you some screenshots from the web mapping tool that we've been developing. So the idea is that this can help contribute to the revisions of Forest Service management plans, and also to inform environmental damage assessments through looking at the changes in services pre and post fire. So this is the homepage it opens up with, and by pressing the Get Started button, that can lead you to the tool itself. So once you open the tool, on the left we have a map. The orange boundary shows the study area, and the green boundary shows the national forest. And there's a variety of different other different data layers that a user can select on if they wish to. And then over on the right are the three sort of choices that a user needs to make first of all. So first of all, selecting the year, and then selecting the fire, and it will give a list of the fires that occurred in that year. And then finally, the ecosystem service. And there are 6 services, as we've just heard earlier in the talk, that a user can select from. So for this example, we're looking at the slide fire, which occurred in 2007, and we've selected carbon storage. So what you can see in the map component on the left is we can view the spatial data by looking at pre-fire or post-fire carbon storage, or also in this case, as we're doing, is looking at the ravage burn severity data. So we can see areas in red have had between 80 to 100% canopy cover loss. And then we can toggle between the pre-fire data, which is showing relatively more areas in blue, so with higher carbon storage. We can compare that with this post-fire map that has more areas of yellow on it. So the outputs can be given as a graph like this, where we have the pre-fire and also the post-fire estimates, and also in tabular format. Here's a screenshot of the outputs for biodiversity. Here we're showing the marks and score values. And in the table on the right, we can see the relevant data for the fire itself in the green font, but we also show the values for the 4 different national forests, so a user can make comparisons. And then finally, recreation. This is an example from the Thomas fire. We can see these blue recreation points and the labels associated with them, with the names. And there in the number is the code number in the NVIM survey. And for those points, we can see data. For example, here on the right, we've got the predicted total number of visits per year. And finally, there's a variety of ways that we can extract the data, either in tabular format, or the spatial data can be downloaded, and then it can be integrated with other data in GIS to further make decisions. So the online web mapping tool is in the final stages of development, so should hopefully be ready soon. And I'd like to leave it there, but also to acknowledge all of the partners and collaborators that have been involved with the project, and also the funding sources. Thank you.